Alright, Chapter 7 review number 26. Round hole of radius square root of 3 feet is bored through the center of a sphere of radius 2 feet. Find the volume of the piece cut out. Alright, so we've got our sphere with a radius of 2. And then we've got a drill that's going to go right through the sphere and bore out a hole with a radius of square root of 7. Alright, so we'll say it goes to like right here and right through it like that. And it's going to go through it down here also. So I think of this as like an olive. I even have green and red here. So I've got the green part of an olive, and then I don't even know what that's called on the inside. Starts with a, I don't know, P, starts with a P? Pigment? I don't know. So there's my olive. We want to figure out how much red stuff there is. Find the volume of the, let's see, find the volume of the piece cut out. So we want to know the red stuff, how much red stuff there is. So on my olive, and then it goes through the middle of it also, but this would all be green stuff. Might as well give it some color here. Okay, there's a couple ways of doing it. We could just we could find the area or the volume of this red stuff, double it, and then we'll have to figure out like the tunneled, like the red stuff on the inside, and add up all those volumes to get how much red stuff we have. So I'm going to start by finding the volume of this much of it. So since the radius of our sphere is 2, the equation of this is the square root y equals square root of 4 minus x squared. If you didn't know that, you could say x squared plus y squared equals 4. That's the equation of this circle. So if you solve for y, it'd be plus or minus the square root of 4 minus x squared. We only are going to use the radius here. We don't need the negative one. Alright, so finding this red air volume, it'd be the integral of pi r squared, where this is your r, which is just 4 minus x squared, square root, from -2 to something. So we need to figure out what that is. Section. This line going across is y equals square root of 3. That's given because that's the radius of the drill. So square root of 3 equals the square root of 4 minus x squared. Where do they intersect? So 3 equals 4 minus x squared, so x squared minus 1 equals 0, so x equals plus or minus 1. So this is -1, and that's 1. Okay, so they intersect at -1 and 1 here. And we're going to integrate from here to here. Just to deal with positives, we might as well just go from 1 to 2. And do this half, because it's the positive half. So 1 to 2, integral of pi r squared. So it's integral, let's see, 4 minus x squared dx from 1 to 2. So find the antiderivative. So pi there from 1 to 2. So it's pi times 8 minus 8 thirds minus 4 minus 1 third. Hope I didn't go too fast there. So 24 thirds minus 8 thirds is 16 thirds. 12 thirds minus 1 third is 11 thirds. So 16 thirds minus 11 thirds gives me 5 thirds. So 5 pi over 3 would be the volume of this little chunk. We're going to double it. So we have both of these chunks, so I have 10 pi over 3 so far. so far I have 10 pi over 3. Now we have to figure out the inside red volume. Well, you can imagine that's just going to be a cylinder, so we could actually just find the volume of a cylinder with a radius of square root of 3 and a height of 2 if we wanted to. Using our disk method, I guess I'll do that as long as I mention it. So the volume of a cylinder is pi r squared times the height, which is 2. So that gives me 3 times 2, so I get 6 pi. So we should get 6 pi for an answer there. Let's try our disk method approach. So it would be integral of pi r, which is the square root of 3 squared dx from -1 to 1. So it's integral of pi times 3 dx. So antiderivative of 3 pi is 3 pi x from -1 to 1. So that gives me 3 pi minus -3 pi, which gives us 6 pi. Alright, so I have the 6 pi plus 10 pi over 3. So 10 pi over 3 plus 18 pi over 3 gives me 28 pi over 3 for the volume of the red. Is it pimento? Is that what it's called? I can't remember. So the red stuff is that 28 pi over 3. So that's one way of doing the problem. Another way that some of you may have thought of is to find the volume of the whole thing, the whole sphere, and then just subtract the green. So if you can imagine, the green is hollow. We're just revolving this much around the x-axis. So you can find the volume of the sphere and then just revolve this around the x-axis and then subtract the two amounts and you'll have the red stuff. So if you're finding the volume of the whole sphere, you could revolve this curve around the x-axis to find the volume of a sphere, or just know that it's 4/3 pi r cubed. So you can find the volume either of those two ways, and then you'd have to use the washer method around the x-axis, where your big R is this equation, your little r is the square root of 3, and get that volume and subtract the two. You should end up with 28 pi over 3 either way.